Questions on that note? Any questions on the bell work? All right, any questions on the homework that was due today? Yeah, Nick. Numero.
Okay, wait. You didn't put 47 on. Was it the same?
Oh, let me go over that real quick. So I think from now on, I'm always going to give one that doesn't have either the work down or the answer to, or it might be just blank. What that's going to be is kind of a sign that I'll probably pick that one to check the next day to see if you have it correct or not. It doesn't necessarily have to be 100% correct, but I do need to see valid work on that. I'm just trying to refrain people from just going online and just copying the answer key because they run out of time. Because like I said at the beginning of the year, and we haven't had this conversation in a while, it just doesn't pay to copy answers off the internet. If you really, really, really desperately need 10s across the board, it's just kind of meaningless because you could get 10s across the board on all your homeworks, and then you do poorly on the test, and you fail the class. Even though you did all the homeworks, you got 10s because you went online religiously and copied all the answers down, and you got the 10 points every single day. Versus someone that gets 5s on all the homeworks and does well on the test, they're going to do well in the class. The homework isn't the major part of this class. It is the tests. And that's why I'm not super strict on when you turn in homework. If you forgot a homework and you turn it in the next day, I give you full points for it. And it's because I think the most important part is that you do it, you understand it, and you can do well on the test. It's not so much that you get 10s across the board because you copied stuff off online. So if you're someone that just copies stuff online so they get the 10, you're doing yourself a giant disservice and you figure it out on the test. You're that student that has 10s on everything and then all of a sudden has like a 50% on the test. Is because you just copied stuff online and you didn't really take it seriously. So that's why it was blank.
Is it the same?
It is going to be the same as that, actually. Yeah. And I was just going to walk around and I'll tell you if you got it right or wrong, basically. And I'll tell you what you did wrong. But if you don't show me any work and you just have a matrix as your answer and it's wrong, that's where you're going to lose the 2 points. So you're at 80%. Yeah.
And then 21.
Yes. I bet you I know what you did. If you look above it, it says you're supposed to do B times A. I bet you did A times B.
I don't...
Let me take a picture of it, and then we'll see where we go from there.
I'm not sure if I did or not. I couldn't tell.
So B is the one with all the 1s in it. So you should have put that first.
Oh, yeah, I definitely did A times B.
Yeah, it seems like the most. Yeah. That's what's recurring on all the classes.
I told myself, make sure you don't do that.
You do. It's one of those things. It's don't do this. Oh, I did it. Yeah. So just flip it around, and then you get the right answer. I'm sure that's yes. 73. Do you have a specific question on 73? So 73. Did you end up getting the? Because I don't have the actual problem written down. I think I just have the answer written down. Did you end up getting the equation 2x plus 3y equals 5 and 4x plus 6y equals 9? If you try to solve that, no matter which method you'd use, like substitution, elimination, you're going to end up with the variables dropping out.
Okay.
And you come up with like 0 equals something. I think if you use elimination, let's say you multiply that first one by -2. And then you use elimination on that, all your variables are going to drop out, and you're going to get 0 equals a -1.
Okay.
And yeah, that's what makes it weird, is that 0 equals -1, you have to put that's inconsistent. All right. Does that help?
Yeah.
Okay, good. Yeah.
For the ones that you don't put like an answer to, couldn't we also like use our calculator and just like put the matrices in and do like A times B? Cause, like, the different
Yeah, but I'm looking to make sure you have work.
Oh,
remember on homework, I'm checking your work too.
Yeah.
Just answers. Answers that I couldn't do in my head shouldn't be answers that you're doing in your head. And this is stuff that has to be done by hand because on the test, I'm going to say you can't use a calculator on this part.
Alright.
Yeah.
Like if we're one of those people who like rocks on the floor at night because we can't sleep, thinking like did we get
You
it
can
wrong?
check it that way. And what I might do is I might just put the answer on the bottom in a small corner and then just not have any of the work down that you have to show my work. So that's one more you have to show your work on the homework, all right? These are by hand right now. I know you can use your calculator, but you need to do everything by hand. And I think on the assignment here I said you can use your calculator to check it, but you do have to do it by hand. Good rule of thumb is if I can't do it in my head, or I struggle to do it in my head, you probably aren't doing it in your head. Okay, so that being said, let's start on the inverses of matrices. Pretty quick lesson again. So you shouldn't have much or any homework over the weekend, which is was pretty nice. But you do have a test coming up on Thursday. So it might be a good idea just to review some of the old concepts over the weekend because you save that time not having math. I'm not saying you have to spend 6 hours studying, but it's always a good idea to just look back at old lessons we did. Make sure you can do that Gaussian elimination. Remember the term Gaussian elimination and how to do it. All right, so inverses of a matrix C. Well, if you look right above in our bell work, those are actually inverses of each other. Those are matrices that are inverses of each other. And if you think about inverses, inverses are basically things that undo what the other one did. And mostly we see that in terms of 1. So we did like sine. Sine inverse of sine, they eliminate each other and they're left with 1 times whatever you have. Multiplication, if I have 3 times x, the inverse of multiplication is division, so you multiply by 1/3 to turn that 3 into 1. Now, normally, the result of multiplying by an inverse usually results in 1. However, in matrices, you can't just have 1. You have to have several numbers. So instead, with matrices, if you multiply a matrix by its inverse, that result is going to be the identity matrix. It's also going to be the identity matrix if you flip the two things. So if I do the inverse times the original, that will also result in the identity matrix. Now here's the important thing. So what you're thinking about is, well, A times the inverse has to equal the identity, and the inverse times A also has to equal the identity. Both of these must be true in order for them to be inverses. So both must be true.
I stands for inverse, right?
Yes. No, I stands for identity, actually. Inverse is going to be this -1 that's hanging out on top. This is kind of the universal sign of inverse, that -1. So both of these must be true for them to be inverses, for A and A inverse to be inverses.
The weird thing about matrices is that the way, if you do A times B versus B times A, it matters.
It absolutely matters. And that's why both of these ways have to be true for it to be the identity. So both of these have to equal our identity matrix in order for them to be matrices, both directions. Which means you have to check both directions. Jack, did you still have a question?
Oh yeah, I was just wondering if, because both have to be true. I was wondering. So then, whenever you want to determine if they're inverses, you have to do both.
You have to do both.
Cool.
Yep. Okay. The other big thing on this is the product is commutative and only. Let me highlight this in red. Where's my red highlighter? Because this is important. Only square matrices have inverses. And I'm going to stop on that for a second and I'm going to explain why only square matrices have inverses. And it has to do with the fact that the result has to be the identity matrix. So a good reason why they have to be square is because if you multiply two things together and the result is something that looks like this, maybe even you have zeros down here, that is not officially the identity matrix. The identity matrix has to have ones going all the way down in order for it to be the identity matrix. So if the result isn't going to be a square, then it can't have an inverse to begin with, because the result can't turn into the actual identity matrix. So the big thing is only square matrices have inverses.
That's
It makes your life a little easier, because if it's not square, then you're just, I'm not doing it, man. I can't. Let's do this first example. And we'll talk about why people are going to lose points on the test. Let's call this one matrix A, and we'll call this one matrix B. So this one says determine whether this and that are inverses of each other. By determining, I have to prove they're inverses. We're going to find out how to actually find inverses. If I'm asking you to prove, you have to do this multiplication. If I ask you to find, then you actually have to find it. Do not find the inverse to prove it. Proving includes multiplying both directions. All right, so the first way we're going to go is A times B. We're going to do matrix A times matrix B. I can't write too big, otherwise I run out of space really quick. So we have 3, 4, 5, and 7, and we are multiplying that by that 7, -4, -5, and 3. I always do this check. I write down below. I know we know this one's going to work, but just get in the habit of writing the 2 by 2, 2 by 2. Those are equal, so I can do the multiplication. And it's going to result in a 2 by 2 matrix. So this is going to equal, we are going to do row times column. So this is 3 and 5 times that column, and then we multiply it by that column. Nope.
Wait, yeah, that
No one stopped me.
no sense. I was like, what?
Okay. As long as, but no one said anything. All right, so that's my row. That's my column. So that's exactly what I did on these first two on the bell word possibilities. What happens if you quickly do that? So we have row times columns. So our first thing is going to be that 3 times that 7. Then we have 4 times that -5. So plus 4 times that -5. Then we move to the next column, and that's the -4 and 3. So we're going to have 3 times that -4 plus 4 times that 3. That's the end of my first row. Now we move down to the next row, which is going to be that 5 and 7. Remember, knowing our patterns, these 5 and 7s are just going to replace these 3s and 4s. The ones I have in parentheses are going to remain. It makes things a lot easier and faster if you do that. So we have 5 times 7 plus that 7 times that -5. Once again, that 5 is going to change out, or that 3 is going to change out with a 5. -4, and replacing that 4 with that 7 times 3. Erase that. All right, this will in fact equal the identity matrix 1, 0, 0, 1. This is what people are going to do in the test, and they're going to say it is in fact inverses of each other, and they're going to lose 2 out of 4 points. You have to do both ways. You did half a problem, so I'm going to give you half a credit for it. There are definitely matrices out there that this direction works, and the other direction does not work. So make sure you check both directions. So now we're going to do B times A, so I can get the full points. I really think problems like this separate people that study their notes and people that just do the review very quickly and think they got it all. Make sure you go through your notes. So we're doing B times A this time. So we have 7, -4, -5, 3 times my A, which is going to be 3, 4, 5, and 7. And I'm going to let you finish that up. It should work. All right, when you show me your work, you should end up with 1 equals the identity matrix. All right, since both of them work, they are in fact inverses. If either one fails, then they are not inverses. If either direction fails, they are not inverses. Yeah.
I'll ask you later.
Okay. Is it on finding inverses?
Yeah.
Okay. On the next slide, we're going to talk about how we can find inverses on our own. Now, there's two methods. There's two methods to find inverses. We're just going to use this one. It's easier, but it has some limitations to it. Let me just really quickly talk about the other method, because I like to at least show it. If you're doing linear algebra or something, you will learn this method and you'll have to use it. So the other method that we aren't learning today would look something like this. Let's say I'm trying to find the inverse of 2, 6, 7, 9. I'm told to find the inverse of that. We can do that by setting up the identity on the other side, which is like an augmented matrix just like we had before. Yeah?
Would that be 9, -6, -7, and 2?
Would it be 9? Would that be the inverse of it?
Yeah.
It would not be 9. 18. It would not be 9. We'll talk about how to find the inverse, because it shouldn't be 9 in the top. Were you just flipping stuff?
Yeah.
Oh, okay. No, we have to do something else. If I was to actually solve this to find the identity, we would do this just like Gaussian elimination. We would say this needs to become a 1. So I'd multiply the entire row 1 by 1/2. Then I'd figure out how to make this 7, and I would do that entire row that way. And as soon as we get this as the identity, the other side would be my inverse. The good thing about this method is it works for any size matrix that has an inverse. The problem with this method, it only works by 2 by 2 matrices. But the nice thing is, the only ones we're going to solve by hand are 2 by 2. Anything bigger, we're going to use our calculator to find our inverses. All right, just so you know, there's another method out there to get bigger ones. This one only works with 2 by 2 matrices. If you're really interested in the other method, you probably already know how to do it. I showed you how to set it up. You know how to solve for 1s across the board and 0s. That is how you would do it. But let's go to this method. So the inverse matrix, we're going to call it matrix M. I'm going to skip this little section for right now, and I'm going to talk about our determinant first. We're going to talk about this determinant first, because that should be the first thing you find. The determinant is going to be this number. And do you see these absolute value bars here? Those aren't a misprint. This is the symbol for determinant. You just put absolute value bars around the actual matrix, and it means determinant. So you can either write D, or you can put absolute value bars around your matrix, or you can put absolute value bars around M. Absolute value bars in matrix means determinant. Well, our determinant is just take your angles, so your A and D, multiply those together. Then you're going to subtract the other angles multiplied together, so B times C. I find that the most missed part about this is the subtraction sign. A lot of people want to make it plus, because it just seems natural in something like this to just add them together. We are subtracting. And why I think a lot of people turn this to a plus is because you're so used to doing that multiplication, where you basically take this times this plus the other thing. You kind of mix the two things together. Determinant is subtraction. Circle that, underline it, however you can, so you remember that it's actually subtraction in this one. All right, as soon as you find your D, our determinant is going to go underneath every one of our elements, like we can see here. We're going to shift around the elements just a little bit, though, because if you look here, our A and D actually switched places. So you are going to switch, that's what our step 1 says here. We're going to switch our A and B values. Our next thing is we're going to take the opposites of C and B. Did I say we're going to switch C and B?
No.
I didn't say we're going to switch them. We're just going to change the sign out in front. And then all you have to do is divide everything by that D. That is all the steps you need to find the determinant. It goes really, really quick. Typically, as long as you find your the determinant correctly, you have the correct answer. Let's see an example of that. So we have 3, 5, 5, 9er. So our determinant, we're always going to find our determinant first. Our determinant is going to equal our 3 times our 9 minus our 5 times our 5. Once again, that's our A times our D minus our B times our C. 3 times 9 is 27 minus 25. Our determinant is going to equal 2. Let's do this step by step. Normally you wouldn't do this, but just for the sake of notes. Step 1. Our step 1 is to interchange our 3 and our 9, so it's going to be 9 and 3. Those two things switch places. Our step 2, according to the steps up there, is I'm going to change the signs in front of our B and C values. So our new matrix we're looking at would be 9, -5, -5, and 3. Step 3, and our final step, is just divide everything by that determinant, which is 2. So we're going to have 9 divided by 2, -5 divided by 2, -5 divided by 2, and 3 divided by 2. And that is, in fact, our inverse.
So the reason that didn't work in this problem is because in the other problem, when I realized they were like switched and opposite and stuff, the D was equal to 1.
Oh, okay. Was the D equal to 1 on that one?
On this one, in the first one. I'm talking about the one where we...
Oh, okay. You were actually trying to find the inverse of it to make sure it was correct. I gotcha. All right, I want you to do the next one. So our D, that's going to equal 1 times 3 minus a -3 times a -1, which equals 0. Here's the problem here. I'm supposed to divide everything by 0. You can't divide stuff by 0. That is undefined, which means every one of these numbers is undefined, which means if your D is ever 0, there is no inverse. That actually has no inverse. And if I'd set this up as some kind of equation, you'd find out really quick it's either inconsistent or it's dependent, which means it has no inverse. And that goes back to our notes here. That's why it says I didn't finish the statement, or I didn't say it. If D cannot equal 0, if D equals 0, there is no inverse. That is all you have to write. No inverse. If D equals 0. Yes?
On the first example, so the inverse of the matrix 3, 5, 5, 9 is 9 over 2, -5 over 2. Like, that's the inverse? Oh, okay.
So if I would take this matrix 3, 5, 5, 9 and multiply it by this, you'd get the identity out.
Oh, okay. So if we get like if all like if it were like even numbers and they were over 2, should we like?
You should simplify. Yes, absolutely. Those are just fractions that I can't simplify.
Are we? So we can't do like 4.5, -2.5, -2.5.
I would leave them as fractions. I think even in the test I said leave everything as fractions, so I can see you can simplify fractions. Because here on out, fractions are much more powerful than decimals. We try to leave stuff in fractions. They're easier to work with than decimals, and they give you more an exact answer. Quickly, because we were messing it up in the classes, look at the first two problems. People were finding the inverses of these. I'm not asking you to find the inverse in these problems. Let me bring up a blank sheet. It specifically says to do A times I. Remember, I is your identity matrix, and you're trying to show it equals A. You're all supposed to flip that around and go I times A also equals A. So in this first example, you're going to do something like this. 1, 3, 4, 6. And you're going to multiply that by the identity. The identity is always 1, 1, 0, 0. And you're going to actually do that multiplication and make sure it results in this. Over here, you're just going to flip those two and do the exact same thing. I'm just kind of showing you and reinforcing the fact that if I multiply a matrix by the identity matrix, you get that same matrix back out. It can save you time on a test versus trying to actually multiply all this stuff out and find out it is just the same thing. And then you're going to do the same thing for number 3. Everything else is follow the directions.